In this video, let us look at the transformer interturn fault detection. One of the main internal faults within transformers in general are what we call interturn faults. These are incipient faults, which I've discussed in earlier videos, which may not pose immediate threat, but if we let the issue grow, it will lead to winding deformation and even some major insulation degradation. And if we let this grow even further, it will eventually lead to major faults within the transformer. Now, interturn faults for a small amount of turns will produce short circuit current in the turns affected. But this will be very difficult to detect at the terminals of the transformer. Because of these faults will not be picked up by differential protection relays. There are several ways to detect interturn faults. By far, the most popular way is actually dissolved gas analysis, or DGA in short. But it is not an effective method due to the variability of the gas data being collected. Another method is more or less not for this particular usage, but can indirectly detect an interturn fault, and that is the ratio meter test, which is a method to actually determine the voltage ratio of the transformer. But through that, you can infer if whether or not there is an interturn short circuit exists within the transformer. This is very dependent on the accuracy and calibration of the bridge resistors that is being used with this method, however. So if your bridge resistors don't have a lot of accuracy, or that you have not calibrated appropriately, then this may be a problem. The third type of detection method that you can use is the capacitor discharge method, which in this case, it uses a synchronized voltage and current measurement to infer if interturn faults happen. Now, this is actually from a recent article from Open Physics Volume 15, Issue 1, titled Detection of Interturn Faults in Transformer Winding Using the Capacitor Discharge Method. So if you actually want to know more about this particular method, I will more or less recommend you to read that particular article. Lastly, interturn faults can also be detected by using frequency response analysis, by comparing the impedance magnitude of windings when it is in healthy conditions versus when you're trying to detect it when you suspect that there's a fault, incipient fault occur. This is mentioned in an article titled Detection of Winding Interturn Faults from Transformer magazine back in April 7th, 2020. If you want to learn more about electrical transformers, particularly in testing and doing diagnostics, I recommend you to check out my Udemy course, Electrical Transformers Testing and Diagnostics course. Now, this is an intermediate video course where you will learn all about electrical transformer troubleshooting that are essential in working within this industry, from general failure investigation methods to specific transformer tests, such as the dissolved gas analysis. So if you're interested in electrical transformer testing, troubleshooting, etc., please check out my course by clicking on the link in the video description.